Hi, welcome to the 4th Analytical Geometry tutorial. This tutorial is merely a recap of all of the work covered in the first 3 Analytical Geometry tutorials. So, in terms of what you need to know, you need to have gone through the first 3 Analytical Geometry tutorials and all of the accompanying exercises, and you also need to be familiar with your grade 10 work. I want you to have a go at the following exercise. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read P, Q and R are points on a set of axes. P is the point 6 and 7, Q is the point 1 and negative 2, and R is the point 3 and A. The first thing I asked you to do was to calculate the distance PQ. Now PQ is going to be given by the distance formula, or rather we can calculate it using the distance formula, which says that that will be y2 minus y1 squared plus x2 minus x1 squared, all in the square root. That's going to give us square root of y2 minus y1, which will be 7 minus minus 2, or 7 plus 2, squared is 81, plus x2 minus x1, 6 minus 1 is 5, squared is 25, which gives us square root of 106, and we can leave it in that form. That is the distance PQ. Now in the second part of that first question, I asked you to calculate the coordinates of A. In order to do that, we are going to have to look at the other bit of information I gave you, which said that PQ is equal to RP, or rather 3RP. PQ is equal to 3RP. Now PQ we know is square root of 106. PQ we know is 106 units. Keep in mind always to say units when we are working with analytical geometry. If we are looking for distances, we use units. Unless we have been given units, for example centimeters or whatever. So PQ is equal to 106 units, is equal to 3 times RP. To get the distance RP, we're going to have to use again the distance formula. RP is going to be given by y2 minus y1, which is A minus 7 squared, plus x2 minus x1, which is 3 minus 6 squared. I can get rid of both square roots. First I've got to get rid of that 3 in front of that square root, so I'm going to make it 106 divided by 3. Then to get rid of that square root, I square both sides. If I square that side, it gets rid of the square root. What I do to one side, I do to the other. That means that A minus 7 squared plus 3 minus 6 is going to give me negative 3 squared is positive 9. Positive 9 taken across will become negative 9. Root 106 squared is equal to 106. 3 squared is equal to 9. Get this to a common denominator so we can add and subtract. Instead of saying minus 9, I'm going to say minus 81 over 9, which is the same as minus 9. 106 minus 81 over 9 means that I can work it over a common denominator. 106 minus 81 is given as 25. That means that a minus 7 squared is equal to 25 over 9. To get rid of this squared, I square root that side. What I do to the one side, I do to the other. And remember, it can be positive or negative. That means that a minus 7 on its own is equal to positive or negative 5 over 3. A minus 7 is equal to plus or minus 5 over 3. That means that a is either equal to, take the 7 across, that will make it positive 7. A is equal to 7 plus 5 over 3, or a is equal to 7 minus 5 over 3. 7 plus 5 over 3 is the same as saying 21 over 3 plus 5 over 3, which is 26 over 3, or a is equal to 21 over 3 minus 5 over 3. 21 minus 5 is equal to 16 over 3. 26 over 3, we can simplify that if we want to. We can turn this into an improper fraction. 3 goes into 24 8 times, our remainder is 2 over 3. Or at the bottom, 3 goes into 15 5 times with a remainder of 1 over 3. Our two possibilities of a are 8 and 2 over 3 or 5 and 1 over 3. What does that mean? That means that there are two possibilities that a can have in order for Rp to be a third of the length of PQ. Basically, the a value, remember, is our y value of R. 8 and 2 over 3 means that it's going to be a little bit higher than the p value, so it's going to be somewhere over there. Or the other alternative is that it's at 5 and 1 over 3, which is going to be a little bit lower, so it could be there or there. There are two possibilities. The second one I gave you to do had this graph over here, OABC, where OABC is a parallelogram. OABC being a parallelogram means that the lines OA and CB or BC are parallel, as well as OC being parallel to AB. I also said that OA is given by the equation y is equal to a negative a half x, and theta is equal to 45 degrees. The first thing I asked you to do was to give me the equation of CB. Now, in order to get the equation of CB, remember it's going to be a straight line in the form y is equal to mx plus c. Y is equal to mx plus c, that's the standard form of this equation CB. We need to start by looking for our gradient. We do not have 2 points in order to calculate our gradient from. However, we know that CB is parallel to OA, which means that the gradients have to be equal. The gradient of CB has to equal the gradient of OA, which is equal to negative 1 over 2. That means that the equation CB reads y is equal to negative 1 over 2x plus c. To calculate c, we substitute the point that we do have in, which is x is equal to negative 2, y is equal to 4. That means that 4 is equal to negative 1 over 2 multiplied by negative 2 plus c. That means that c is equal to 4. Negative 1 times negative 2 is going to give me positive 1. Taken across becomes 4 minus 1, which is 3. That means that the equation of CB now reads y is equal to negative 1 over 2x plus 3. That means that that point of intersection is 3. Y is equal to 3. The next thing that I asked you to calculate is the equation of AB. Now, in order to get the equation of AB, again, I'm going to have to start by looking at gradients, because it's y is equal to mx plus c. In order to get the gradient of AB, I don't have the coordinates of A, so it is going to be very difficult to calculate that gradient by using AB, but remember it is a parallelogram, which means that the gradient of AB is equal to the gradient of OC. M of AB is equal to the gradient of OC. Now, we also know that M is equal to 10 of theta. Theta is 45 degrees. Theta is the angle of inclination of OC. So it's equal to 10 of 45 degrees. That means that the gradient of AB is given by 10 of 45, which is 1. That means that our equation AB reads y is equal to 1x plus c. To get the coordinates of C, I'm going to have to substitute a point in that I have. I've got point B on AB. Remember, we're looking at the equation of AB. Substituting that point in, it's going to read 4 is equal to negative 2 times 1 is negative 2 plus C. That means that C is equal to 6. That means that the equation of AB reads y is equal to 1x, or just x, plus 6. The next thing that I asked you to calculate was the coordinates of A and C. Now just keep in mind that the equation of BC was given by y is equal to negative a half x plus 3, and the equation of AB was given by y is equal to x plus 6. Let's keep that in mind. Now, we are going to start by looking at the coordinates of A. Is A not the point of intersection between the lines AB and OA? So at A, OA is equal to AB. Now OA is given by negative a half x, is equal to AB, which is given by x plus 6. If I solve for x, this means that negative x is equal to 2x plus 12. Got rid of that denominator. Take the 2x across. It means that negative 3x is equal to 12. That means that x is equal to negative 4. How do I find my y value? I can substitute this x is equal to negative 4 into either of these equations. Sorry, not either of these, into either AB or that equation. If I substitute x is equal to negative 4 in there, it means that y is equal to negative 4 plus 6, which is equal to positive 2. Which means that my coordinates of A are given as negative 4, positive 2. Just out of interest, if I substituted x is equal to negative 4 into there, y is going to equal negative a half times negative 4 is equal to positive 2. So those are the coordinates of A. To get the coordinates of C, I'm going to follow a similar process. The only problem is I don't have two equations to work with. Not yet anyways. I do have this equation over here, BC, which is given by y is equal to negative a half x plus 3. I can calculate the equation of OC. Remember, it's I can calculate the equation of OC. Remember, it's given by y is equal to mx plus c. I know that my gradient is 1. That means that it reads y is equal to x plus c. To get my c value, I substitute the only other point that I have, which is going to be 0, 0. 0 is equal to 0 plus c. That means that c is equal to 0. That means that the equation of OC is given as y is equal to x. 1x plus 0, or just x. Now, let us look at calculating the coordinates of C. C is the point of intersection between BC and OC. That means that x is equal to negative 1 over 2x plus 3, which means that 2x is equal to negative x plus 3, plus 6, because I multiplied the denominator out. Take that across, that becomes 2x plus x. 3x is equal to 6. X is equal to 2. If x is equal to 2, remember my equation of OC says y is equal to x. That means that if x is equal to 2, y is also going to equal 2. Those are my coordinates of C. C is going to be given by 2 and 2. I then asked you to calculate the distance AC. Very simply, we're going to use the distance formula. AC is equal to square root of y2 minus y1, which is going to be 2 minus 2 is 0 squared, plus x2 minus x1. 2 minus minus 4 is going to be 2 plus 4, which is 6 squared, which gives me square root of 0 squared is 0 plus 6 squared is 36. Square root of 36 is equal to 6 units. AC, the distance AC is given as 6 units. I then asked you to calculate the size of AOC. AOC, that's that angle over there. Not a difficult one to calculate. I can do that calculation by using gradients. To calculate the size of angle AOC, I can do that using gradients. Wouldn't the angle of inclination all the way from there till there be given as m is equal to tan theta? Or let's call that something else. Let's call that alpha. Now alpha, to get alpha, we're going to need the gradient of AO. The gradient of AO, or OA, remember the equation of OA is given by y is equal to negative 1 over 2x. That means that the gradient is negative 1 over 2. Tan alpha is equal to negative 1 over 2. That means that alpha is going to equal second function tan of that. But what I'm going to do is I'm first going to work out the second function 10, or the inverse function of positive 1 over 2, which is going to give me an answer of 26.56, or rather 27 degrees. That's that angle over there, 27 degrees. So to get alpha, I'm going to say 180 degrees minus 27 degrees, which is going to equal 153 degrees. That means that alpha is equal to 153 degrees. Now remember, we are looking for AOC. AOC is going to be given by alpha minus theta, the big angle minus that small angle over there, to be left with that. So that's going to be 153 degrees minus 45 degrees. 153 minus 45 is equal to 108 degrees. The third one I gave you to do had a right angle triangle PQR, with RP or PR the hypotenuse, Q the coordinates 3 and 5, R the coordinates 4 and B, and P the coordinates -2, -1. Angle QPR is given by beta. Let's just write that over there. That's beta. And M the midpoint of PR. The first thing I asked you to do was to determine B. Now in order to do that, remember that B is part of the coordinates of R. PQ and QR are perpendicular to each other. That means that the gradient of PQ multiplied by the gradient of QR should equal -1. The gradient of PQ is going to be given by y2 minus y1, so it's -1, over x2 minus x1, which is -2. That multiplied by the gradient of QR, the gradient of QR is going to be given as y2 minus y1 over x2 minus x1, and that has those two multiplied by each other have to equal -1. 5 minus -1 is 5 plus 1, which is 6. 3 plus 2 is 5. 6 over 5 multiplied by b minus 5 over 1 is equal to -1. That means that b minus 5 is equal to -1 multiplied by 5 over 6, to get rid of it on that side. That means that b is equal to -1 times that, which is equal to -5 over 6. Take the 5 across, it's going to become +5 or +30 over 6, common denominator. That means that b is equal to -5 plus 30, which is 25 over 6. You don't need to simplify it any further. If you do want to, that can become 6 into 24 4 times, remainder 1 over 6. So the coordinates of B are going to be given as 25 over 6. I then asked you to calculate the coordinates of M, which is the midpoint of P. I then asked you to calculate the coordinates of M, which is the midpoint of PR. That's going to be given as y2, 25 over 6, plus y1 over 2. Sorry, this is the y coordinate. We start off with the x coordinate, which is going to be 4 plus -2, or 4 minus 2 over 2, and y2, which is 25 over 6, plus y1, which is negative 1, so it's going to be minus 1 over 2. 4 minus 2 is 2 over 2 is 1. 25 over 6 minus 1 is the same as 25 over 6 minus 6 over 6, which is 25 minus 6 is going to give me 19 over 6 divided by 2, which is the same thing as 19 over 6 multiplied by 1 over 2, which is the same as 19 over 12. That means that the coordinates of M are given by an x value of 1 and a y value of 19 over 12. I then asked you to calculate the size of RPQ, or rather the size of beta. Now, in order to get the size of beta, we are going to have to look at gradients. First, I'm going to look at the gradient of PQ. M of PQ, the gradient of PQ is y2 minus y1, which is 5 plus 1, which is 6, over x2 minus x1, so that's 5. So the gradient of PQ is equal to 6 over 5. That means that the total angle, theta, angle of inclination, is equal to the inverse function tan of 6 over 5, because remember, M is equal to tan theta. That means that theta is equal to the inverse function tan of the gradient. If I find this inverse function of 6 over 5, that's going to give me an answer of 50.19 degrees. So I'm going to leave it as 50.2 degrees. 50.2 degrees is that angle theta. Now let's look at the small angle here. Let's call this alpha, because remember, the big angle minus that small angle is going to give us beta. So to get that small angle, that's the angle of inclination of PR. Again, we're going to say the gradient of PR is going to be given by 25 over 6 y2 minus y1, so it's plus 1 or plus 6 over 6, divided by x2 minus x1, which is going to give me 25 plus 6 is 31 over 6, divided by 4 plus 2 is 6 over 1, or rather multiplied by, tip and times, multiplied by 1 over 6. 31 over 6 multiplied by 1 over 6 is going to give us an answer of 31 over 36. Now remember, we know that alpha, that angle over there, that small one there, is equal to tan, or rather M, gradient of that, gradient of PQ, PR, is equal to tan of that angle, tan of alpha. But we know that the gradient of PR is 31 over 36, which means that alpha is equal to the inverse function tan of 31 over 36, which means that alpha is equal to 40.7 degrees. Now look at this carefully. Remember, we're trying to work out beta. Alpha is 40.7 degrees. Theta is equal to 52 or 50.2 degrees. That means that beta is going to equal theta, which is 50.2 degrees, minus alpha, 40.7 degrees, is equal to 9 9.5 degrees. And that is the angle QPR, or the angle beta, 9.5 degrees. The fourth one I gave you to do had the triangle ABC with coordinates A, 6 and 4, B's coordinates 3 and -4, and C's coordinates P and 2. I also said that angle CBA or ABC is equal to theta degrees. CA is given as being equal to BA. Calculate the coordinates of C, or rather the value of P. To do this, we're going to use the distance formula. The distance formula says that CA is going to be given by square root of y2 minus y1, which is going to be 2 minus 4 squared plus x2 minus x1, which is going to be p minus 6 squared, and that has to equal, let's just write this out properly, that's going to be 2 minus 4 all squared plus y2 plus x2 minus x1 squared is equal to square root of, now that was the distance of AC or CA. The distance of AB is going to be given as 4 minus minus 4, or rather 4 plus 4 squared plus 6 minus 3 squared. Now I can start this one out by getting rid of the square root sign on both sides. All I'm doing is squaring both sides. 2 minus 4 is equal to -2 squared is positive 4, plus p minus 6 all squared is equal to 4 plus 4 is 8 squared is 64. 6 minus 3 is 3 squared is 9. This means that p minus 6 on its own is going to equal 64 plus 9 is 73, minus 4 is equal to 69. Square root of it means that that's going to equal square root 69, positive or negative. That means that either p is equal to take the 6 across 6 plus root 69, which is equal to 14.3, or p is equal to 6 minus root 69, which is equal to -2.3. Now the reason it's given us two answers is because p could fall either there, or it could be somewhere over there. Same y value, it could fall somewhere over there, which would make AC equal to AB. So it could be over there, but in this case we are looking for this example, or for the negative x value, which means that p is going to equal -2.3, and the y value still is 2. That is point P. I then asked you to calculate theta, or rather angle ABC. To get theta, we're going to have to take the big angle, which is the angle of inclination of BC, which will be taken by the gradient of BC. That big angle minus the small angle, which would be given by the gradient of AB, would give us the angle theta. I'm not going to do that calculation with you. I've done it enough times before. You have to come to an answer though of 62 degrees rounded off. And that is what theta is equal to. The last one I gave you to do read PQR is a triangle with points P -2 and B, points Q 5 and 1, point R -2 and A. PQ cuts the y-axis at +3, QR cuts the y-axis at -2, M is the midpoint of PR. I started off by saying find the values of A and B. Now look at this carefully. Oh, also I said that PQR is an equilateral triangle. To do that, we can say PQ is equal to QR, which is equal to RP. And then we could use the distance formula for all of these and get some nice simultaneous equations. That would be difficult though. But have a look at this. The equation of PQ is a straight line, so it's going to be given as y is equal to mx plus c. Do we have 2 points? Yes, we do. That's the point x is equal to 0, y is equal to 3. That means to get the gradient of PQ, we can say y2 minus y1 over x2 minus x1, which is going to equal 3 minus 1 is 2, 0 minus 5 is negative 5. So negative 2 over 5 is my gradient of PQ. That means that y is equal to negative 2 over 5x plus c. To get c, substitute any point in. I'm going to substitute this point in here. That means that that's negative 2 over 5 times 5 is equal to y value plus c, is equal to a y value of 1. C will equal 3, because that's going to become 1 plus 2. 5's cancel, negative 2 taken across becomes plus 2, 1 plus 2 is 3, or we could just say our c value is our y-intercept. That means that the equation PQ is going to be given by y is equal to negative 2 over 5x plus 3. The equation of QR similarly is going to be given by, again, y is equal to mx plus c. Our gradient is going to be y2 minus y1, which is going to be negative 2, negative 1, which is negative 3, over x2, which is 0, minus x1, which is 5. So that's negative 5. So our gradient is given as positive 3 over 5. Our c value is our y-intercept of negative 2. That means that RQ is given by y is equal to 3 over 5x minus 2. And those are the two equations that we have. To get the coordinates of, firstly, the coordinates of R, we are looking for the y value, but we've got the x value. That means that we're going to substitute that x value into that equation, which means that y is equal to 3 over 5 multiplied by negative 2, which is the x value, minus 2, and that's equal to y, or rather that's equal to a. Negative 2 times 3 is negative 6 over 5, minus 2 or minus 10 over 5, common denominator. Minus 6 minus 10 is minus 16 over 5. That means that the coordinates of A are, or rather A is equal to minus 16 over 5. To get the coordinates of B, we're going to do the same thing into PQ. We're going to say that y, or rather B, is equal to negative 2 over 5 multiplied by negative 2, which is our x value, plus 3 which is going to give us positive 4 over 5 plus 3 or plus 15 over 5, which is going to give us 4 plus 15 is 19 over 5. I don't need to simplify that. If you want to, you can. So A is equal to negative 16 over 5, and b is equal to positive 19 over 5. I then asked you for the coordinates of m. The coordinates of m is the midpoint of PR. So it's going to be given by x2 plus x1. So that's going to be negative 2 plus negative 2 over 2, and a y value of b plus a over 2, or 19 over 5 minus plus negative 16 over 5, which becomes minus 16 over 5, all over 2, which is going to be given by negative 2 and 19 over 5 minus 16 over 5 is going to give me 3 over 5 divided by 2, which is the same as 3 over 10. So my coordinates of m are going to be an x value of negative 2, and we can see that it's going to have an x value of negative 2 because it's in line with the line x is negative 2. X coordinate of negative 2, y coordinate of 3 over 10. The last thing I asked you for was, is QM a height of the triangle? Now, in order for QM to be a height of this triangle, it would mean that QM is perpendicular to PR. If they are perpendicular, it means that the gradient of the one multiplied by the gradient of the other is equal to negative 1. The gradient of QM is going to be given as y2 minus y1, which is 1 minus 3 over 10, or 10 over 10, which is 1 minus 3 over 10, over x2 minus x1, which is going to be 5, minus minus 2, which is 5, plus 2, 7. 10 minus 3 is 7 over 10 divided by 7 over 1, or rather multiplied by 1 over 7. 7's cancel. That gives us a gradient of 1 over 10. That means that the gradient of QM is equal to 1 over 10. Now let us look at the gradient. Let's just write this in here. That's 1 over 10. Now let us look at the gradient of PR. The gradient of PR is going to be y2 minus y1, y2 minus y1, b minus a, or 19 over 5 minus minus 16 over 5, which is plus 16 over 5, divided by the gradient divided by x2 minus x1, which is going to be negative 2 multiplied negative 2 minus minus 2, which is negative 2 plus 2, which is 0. Look at this. We've got an undefined gradient. Our gradient of RP, or our gradient of PR, is undefined because that line is perpendicular to the x-axis. So in order for this line QM to be perpendicular to PR, it would mean that QM is perpendicular not only to PR but also perpendicular to the y-axis, which means that the y value of m would have to equal the y value of q, but the y value of m and the y value of q are not equal to each other, which means that qm is not a height. qm is not a height of triangle. And that brings us to the end of this tutorial. We will go through more examples in the final analytical geometry tutorial titled Advanced Cumulative. The next tutorial we will be working with is titled Circles. It is applicable only to grade 12 learners. However, if you are in grade 11 and you have mastered the tutorials thus far, you are welcome to go on ahead with that. Look forward to seeing you in the next tutorial.